At midnight, the ship P is at a point with position vector -11, -24 kilometers and traveling with constant velocity. 4 hours later, it is at a point with position vector 9 and 20 kilometers. Question A. Find the velocity of P in a vector form. So, initially, this particle is at a point with position vector, let it be R1, and 4 hours later, it's at a point with position vector, let it be R2, and coordinates of R1 is -11, -24, and R2 is 9 and 20. And if we consider this vector is a difference R2 vector minus R1 vector, and it's the displacement vector. And velocity vector can be found as this displacement vector divided by time. It's because it is motion with constant velocity, and the usual formula velocity is distance or displacement divided by time. It will not be true if it is moving with acceleration. And it becomes, time is 4 hours, so it becomes 1/4 R2, 9 and 20 minus R1 is -11, -24, and it becomes 1/4 20 and 44 and 5 and 11 are coordinates of the required velocity vector. The next, at midnight, another ship Q is at a point with coordinates 5 and -10 kilometers and traveling with constant velocity AJ kilometers per hour. The distance between two ships, t hours after midnight, is d kilometers. Question B, show clearly that d squared is equal to this expression. So at any moment of time, position is like a coordinate of P, because position vector is a vector which starts at the origin, and since origin is 0, 0, and a vector, coordinates of a vector are what? Coordinates of the endpoint minus the coordinates of the starting point. Coordinates of a point will have the same values as coordinates of the corresponding position vector. So at any moment of time, position vector of P can be found as the initial position vector, or the position vector of the starting point, it's -11, -24, plus t, and velocity vector. Since it is motion with constant velocity, it becomes velocity time. It's just displacement, and if we add the initial position vector, it becomes like coordinate at any moment of time. So, and velocity, it's found 511. And position vector of Q at any moment of time, it's 5 -10, and plus time, and velocity, it's 0,8. And situation looks like this, that at any moment of time, position of P, its position vector is RP, and position of Q is RQ. And if we consider this vector, it may be RQ minus RP or RP minus RQ. It doesn't matter if you need distance between them to be found. So if we consider RQ minus RP, its displacement vector, and then magnitude of this vector is the required distance between them at any moment of time t. So distance, its magnitude over vector RQ minus RP, or RP minus RQ, it doesn't matter. And what is the magnitude of a vector? It's square root of the sum of squares of the coordinates of a vector. But firstly, let's consider, or let's find coordinates of a vector, and then we can find the magnitude of this vector. So let's consider vector RP minus RQ, and to find coordinates of this vector, we just what? 5 plus 0t minus -11 minus 5t, and -10 plus 8t minus -24 minus 11t, and it's what? 16 minus 5t, and 14 minus 3t, and then distance is equal to the magnitude of this vector, and its square root of the sum of squares 16 minus 5t squared plus 14 minus 3t squared, and if we consider d squared, it becomes just 16 minus 5t squared plus 14 minus 3t squared, and if you expand it, you should get what this. Let's expand. It becomes what, 256 minus 2ab, so it's 160t plus 25t squared plus 196 minus 84t plus 9t squared, and you can see that 25 plus 9 is 35t squared minus 160 minus 84, it's negative 244t, and 256 plus 196, it's 452. Then an observer on P can only see the lights of Q when d is 10 kilometers or less, and to be seen d squared must be less or equal than 100. D less or equal than 10, hence d squared less or equal than 100. C. Given that an observer on P sees the lights of Q for the first time at 2 a.m., so since t0 is at midnight, as coordinates for t, it becomes t is 2 hours. Find the time when the lights of Q move out of the sight of the observer on P. So to be seen, this d squared, this expression must be what, less or equal than 100, and if we move 100 to the left, it becomes 34t squared minus 244t plus 352 should be less or equal than 0 to be seen, and it looks like what? It's quadratic inequality, and it's the graph of this function. It's what? It's a parabola, and concava parabola, and to be seen, y or d squared should be what? Less or equal than 0. It's this region to be seen, and the first time it happens when t is 2 hours, so this coordinates is 2 hours, and we need what? We need just the second root, and if t is greater than t2, it will not be seen anymore. And find the time when the lights of Q move out of the sight of the observer on P. So we need just the value of t2. And in general, to solve the inequality, you need the roots of the corresponding quadratic equation. And to find t2, you may just solve this quadratic equation just using discriminant or just using a calculator, but since I know one root, I can just apply a product rule or the sum rule. For example, product rule says that the product of two roots, 2 times t2, is c over a. C is this, a is this, or sum is minus b over a, so sum is 244 over 34. So product is 352 divided by 34, hence t2 as coordinate, t coordinate, it 352 divided by 2 times 34, and it is equal to 5.18 hours. And to get time we need just convert what? 0.18 hours into minutes. And how to do that? Just multiply by 60 to get 10.8 minutes, but if we round it to the nearest whole minute, it becomes 11 minutes. So time, it becomes 5 hours and 11 minutes, or 5:11 a.m. and it's the required time. And that's all for this question.